Welcome back, everyone, ladies, gents. Hopefully everyone's doing well. We're still on chapter 4. This is now day 2. We're looking at sum and product when we're factoring trinomials. We talked about greatest common factor in the previous video. That will definitely come into play here. Now we're looking at trinomials, and specifically when our a value is 1. What's an a value? I don't know. We're going to find out. This is April 8th. At least this is when the video will be posted. It's grade 10 math. But, as always, anyone who's willing to watch, anyone's looking for information, I'm glad that you're here. My name hasn't changed yet. Probably never will change. Mr. Benjamin. Learning goals for this lesson. First thing we're going to do is describe A, B, and C when working with trinomials. We have talked about these values before. It could just be the case that we've never actually given them the name A, B, and C, but it will make sense when we see it in play. We're going to recall FOIL. It's first outside, inside, last, and factored in standard form, and how these two kind of coincide with each other between foiling and factoring. I'm just going to write fact because I don't have any room there. We're also going to factor trinomials when a is equal to 1, which is basically the whole point of this video. One more thing we're going to do is, let's write this in here, for graph functions, using factored trinomials. And this will bring us back to our previous unit, actually, when we were graphing parabolic functions. So, recalling standard form. We have ax squared plus bx plus c. The a represents the value in front of x squared, as you can see right there. B represents the value in front of x, as you can see there. And C represents, I really should be doing this in the color, the appropriate color, which I've gotten wrong here. That should be green, or orange, or excuse me, yellow. Wow, that was bad. C equals the constant value. Now, in many cases, this can be 0. And there's no variable here. Whereas B and A will always have that variable, x and x squared. Okay, so that will always be there. That will always be there. And this will always be here, but it sometimes could be 0. And that's basically it. In this video, we're going to focus on this a value equaling 1. That was supposed to be a star. Kind of still is. Foiling. Keep in mind, this is first, outside, inside, and last. You might have a different way of doing this. This is how I've learned it, so I'm always going to do it. So, first, let me just underline this. Actually, I'll keep that yellow. We're going to multiply x by x, and that will equal x squared. The outside, let's do that in green. Let's not use green, let's use blue. So my outside values, let's multiply those together. I'll have minus 2x, or negative 2x. Inside, let's do that in yellow. Plus 3x, because I have 3 multiplied by x. And then the last value we'll do in white again. 3 multiplied by negative 2. That should give us negative 6. Now if I look at this function, I have 2 like terms here, so I can collect those. Negative 2 plus 3x, they're both x's. When I add that together, I should end up with positive 1x, so just plus x. And I also have x squared. Continuing there, and then that's negative 6. So this is my answer to be in standard form from factored form, because I foiled. From here to here, foil. Now, if we were to work backwards, if I didn't have this information and I wanted to go back into my standard form, I'm going to keep that there just to show you. But if I wanted to work backwards, I would have to kind of think about how I could get back to x x in brackets, right? Because that's what our factored form looked like. My a value we know is going to be 1. This is my b value, right? A, b, and c. So we said, excuse me, let me erase this and give myself some more room here. That's still minus 6. So we said b is equal to 1 and c is equal to negative 6. So we have to find out what, in fact I'm going to write it here, what two numbers add up to 1 and multiply to give negative 6, question mark. And this is our sum and product. So I have to have two numbers. When you add them together, they'll equal 1. When you multiply them together, they'll equal 6. Could those two numbers be the two numbers we started with? I don't know. Let's find out. Positive 3. And since it's adding, it'll be negative 2. Does that equal 1? I think it does. What if you multiply them together? Positive 3 minus negative 6? Yes, it does. Sorry if the hand's in the way. But bottom line is, our b value needs to add together, and our c value needs to be a product or multiplied together to get that answer. So right here, this is going to be b, or x plus 3, and x minus 2, which is what we had to begin with. Okay. Standard form, like I said, we're looking at sum and product. Okay. We've established that the value that goes in front of this first function, or this first term, x squared, is known as a. Okay? The value that goes in front of, well, let me redraw that arrow. The value that goes here in front of the x is known as b, and c is this constant value. Okay? In these cases, b is our sum, and whites. C is our product, okay? So, if we have negative 5 and negative 24, we have to find out what two numbers give us negative 5 when we multiply them together, and negative 24 when we multiply them. So, two numbers that give negative 5 when added, and negative 24 when multiplied. Multiplied? Is that right? I think it's right. Okay. The way I approach this, I look at my product. I look at the factors of those products. So 24 can equal 1 multiplied by 24, 2 multiplied by 12, 3 multiplied by 8, and 4 multiplied by 6. Okay? Which one of these, if I were to add them together, gives me 5? Add or subtract, and I have negative 5, so might be some manipulation going on there. 1 and 24, that can't be it. 2 and 12, no way. 4 and 6, no. So it's got to be 3 and 8. How can I add 3 and 8 to get negative 5? Okay, well, 3, 8. If I do negative 3 and positive 8, that gives me positive 5. Is that right? No, don't want that. What if I try positive 3, negative 8? Does that give me negative 5? Yes, it does. So, first value, second value. Okay? I'm going to erase... No, I want to keep that. I'm going to erase this right here. If 3 and 8 are my values, that would mean positive 3 multiplied by negative 8 would give me negative 24. Is that the case? I can't draw 4, can I? No. Try that again. There we go. Positive 3. If you multiply those together, yeah, you do get negative 24. Are those the values that I want to get? They are. So, would it be safe to say, and let me write it out in white so it kind of stands out, x squared minus 5x minus 24. When I factor this out, to get my two factors, remember x is in brackets, positive 3 and negative 8. And that is my final answer. Again, I apologize if the hand is in the way. Do a couple more examples. So in this first one, my b value, let me try a different color. B is equal to positive 7. C is equal to positive 12. This is my sum. This is my product. So what two numbers will get me to positive 7? It's a weird looking 7. Try that again. And positive 12. When I multiply them and when I add them, respectively. Any ideas? Okay. How do I get to 12 through multiplication? 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. Right? Could be any one of those. Can't do 1 and 12. 2 and 6 will get me to 8 or 4 if I add or subtract. 3 and 4, let's try it. Positive 7, so it's plus 3. Plus 4. If I multiply positive 3 and positive 4, do I get positive 12? I do. If I add positive 3 and positive 4, do I get positive 7? I do. So that is my final answer. Put my equal sign there. Beauty. Let's look at this one. We've got m now. Okay, so m squared is equal to m squared minus 4m minus 12. So sum, which is b, equals negative 4. Product, which is c, equals negative 12. So what two values give me... Well, we just did that, didn't we? We can look down here. Still isn't 1 and 12. It's not going to be 3 and 4 this time. So maybe 2 and 6. Let's try 2 and 6. Okay. Get rid of all that jazz. I don't want that arrow. Let's try x. We know it's negative. If I do negative 2 and positive 6, when I add these up, I should get negative 4. I'll even write that out. Negative 2 plus 6 equals... Oops. That gives me positive 4, doesn't it? So that's not correct. I want negative 4. Okay. So that can't be it. Let me erase that. I still think it is 2 and 4, though. So let's try positive 2 and negative 6. So plus 2 plus 6, minus 6 equals negative 4. That's okay. And if I multiply positive 2 multiplied by negative 6, that gives me negative 12. That works. We're good. Okay. Some space here. Last option, or last example. Sum, which is b, is negative 10. Product, c, is positive 21. Okay. These numbers look daunting. Let's see if we can find an answer. How do we get 21 when we multiply? 1 multiplied by 21, 3 multiplied by 7, and I think that's it. So it's going to be one of these two. I don't think 1 and 21 will give me 10 if I add them together. So I'm guessing it's going to be 3 and 7. Let's try it out. X. 3 and 7 to get to positive 21. We can try positive 3 and positive 7. Plus 3 plus 7. We need to get a sum of negative 10. That's not going to work, right? Because positive 3 plus 7 is equal to positive 10. So the other option would be to try negative 3 and negative 7. Because I know if I multiply the two negatives, it'll give me a positive. So negative 3 plus negative 7 does in fact equal negative 10. And negative 3 multiplied by negative 7 does equal positive 21. Again, I'm sorry if the hand is in the way, but that is our answer. Let me outline that. Let's outline it in green. So we're good. If we have a situation where a does not equal 1, we can think of factoring, and we will use the greatest common factor amongst our variables, or amongst our terms. So in this case, a is equal to 4. We don't want that. No bueno. That's kind of funny, I guess. Let's get rid of that. Okay, what can I factor out of all of these terms? I can factor x and x, but there's no x there, so I can't do that. So let's look at values instead. 4, 16, and 48, they're all divisible by 2, but they're also all divisible by 4, so I can factor out a 4. If I were to do that, what does this look like? Equals 4 multiplied by x squared plus divided by 4 is equal to 4. 4x. And 48 divided by 4 is equal to 12, I think. So subtract 12. Okay, so x squared, 4x, negative 12. Sum. 4, product. Negative 12. So what two values will work here? 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. I think it's going to be 2 and 6. Let's try it out. Positive 4. I need negative 12 though, so one of my two values is going to have to be negative, one's going to have to be positive. So let's do x subtract 2 and x plus 6. I think that should work out just fine. Let's test it out. Negative 2 plus 6 is equal to positive 4. Negative 2 multiplied by 6 is equal to negative 12. If these values match these values, we're good. I think we are. Good, 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 good. I'll write it out once more. X subtract 2, x plus 6 equals. So in some cases, you're going to have to graph, and we did this in the last unit, so it shouldn't be a problem. We have y is equal to x squared, subtract 2x minus 8. Now this is in standard form. We're going to put it into factored form, so we can find our zeros, axis symmetry, vertex, and graph. We'll draw our graph, I guess, not find our graph. So, sum, negative 2, product, negative 8. What two values give us negative 8 as a product and negative 2 as a sum? Okay, well, how can we make 8? How can we make 8? Okay, we got 1 multiplied by 8. We got 2 multiplied by 4. I think that's it. I really don't think it's going to be this one. 2 and 4. I want to get negative 2 and negative 8. So I know one of my values has to be negative, one has to be positive. If I do negative 4 multiplied by 2, that will give me 8. Negative 4 plus 2 does give me negative 2. So I think it's going to be negative 2. No, what did I just say? Negative 4 and positive 2. X minus 4, x plus 2 equals. Sweet. Okay, so get rid of this jazz, because we know that's our answer, and we can test it if we want to. How do I find my zeros? It's a blast from the past, huh? It's going to be the opposite of what I have here, because it's going to be x minus 4 equals 0, and x plus 2 equals 0. So this will end up being x equals 4. And this will end up being x equals 2. Oh, negative 2. All right. From this, I can also find my axis symmetry. Ax of s will be 4 minus 2 divided by 2, which all equals 1. I'm going to draw that again. It doesn't look like a 1. All right. Now, I can find my vertex. Let's do that in green. Let's see. Let's draw a line here. Vertex. X equals 1 sub into equation. So if we use y is equal to x squared minus 2x minus 8, it's actually let's sub it into the equation we just found, which is x minus 4, x plus 2. I want to do that because we just used it, so it makes a bit more sense. Equals 1 minus 4 multiplied by 1 plus 2. It's going to be negative 3 multiplied by positive 3. Should be negative 9. Therefore, vertex, again, I'm sorry if the hand is here, equals 1 comma negative 9. Right. I got no space to draw my graph, and I'm at 20 minutes. Wow, okay. I'm going to do the graph on this side, and this will leave for another time. What were my values? Zeros were 4 and negative 2. That's 0, negative 2. Say 4 is here. My axis symmetry was 1. The vertex was 1 and negative 9. Alright, should be enough now. Okay, 1, negative 9 is going to be down here somewhere. Put it there. Not the greatest parabola. I'm not very good at drawing them freehand, but that's what our graph would look like. And of course, it's just a sketch. Don't have exact values in here. Again, since we're at 21 minutes, we're going to have people try this one on their own. Try this. Okay. Follow these same steps. Factor it out first. Find your zeros, your axis symmetry, your vertex, and then draw the graph. Green highlighter looks pretty cool to me. We'll do our thank you. Happy face. Hope everyone's doing well. Have a great day.